If you've been watching my other videos, you'll have probably noticed something strange with all my route maps. Take this example of the Southampton to New York route. I always make the ship take a curved path across the ocean. With fuel coming in as one of the biggest expenses, obviously ships normally take the shortest route possible. So why do I use curved lines on these tracks? Well, actually, when you're navigating on a global scale, these curved tracks are shorter than a straight line drawn between the origin and destination. The reason for it is to do with the shape of the Earth and the projection of the chart. We all know the shape of the Earth is spherical. To be a little more precise, it's an oblate spheroid, but for simplicity, we'll just assume it's a sphere. If you take 2 points on the equator, it's pretty obvious that the shortest route is to travel straight along the equator itself. As you move further north though, the shortest route starts to bend towards the North Pole. At this scale it may not be immediately obvious, but if we take it to its extreme and we approach the pole, clearly it's shorter to go over the pole itself rather than following around the parallel of latitude. So it may seem like we're taking a strangely curved path, but actually we are following the shortest path on the surface of a sphere. In navigation we call it a great circle track, and it works between any 2 points on the surface of the Earth. Between Southampton and New York, the shortest route is a great circle. The reason it doesn't look like the shortest route when drawn on a chart is all to do with the projection of the chart itself. The most commonly viewed charts are drawn with a Mercator projection. This is just a method of displaying a spherical Earth on a flat sheet of paper while preserving the right angles between parallels of latitude and longitude. We need to do that so that we can easily read compass bearings from the chart. The downside of the Mercator projection is that it stretches the Earth at the poles, which is why Antarctica looks like it's so large when in reality it just covers a small area over the South Pole. As you get towards the pole, it makes more sense to use what we call a polar projection. Parallels of longitude all converge towards the pole, and parallels of latitude appear to curve. It's very hard to navigate on a polar projection because reading courses is so tough. Imagine you are here following your compass due east. Obviously your compass would give you a constant reading of 090 degrees, but your path on the chart would curve, following the parallel of latitude towards the east. But what if we took a great circle track instead? On the polar projection, the great circle track is a straight line. It's the shortest route between 2 points on the curved surface of a sphere. As the parallels of longitude all converge, the great circle track crosses each one at a different angle, indicating that your compass course would need to constantly change. Plotting on the Mercator projection is obviously different. To plot the great circle track, you know that you cross each parallel of longitude at a different angle. The track now appears curved, which explains why I've always drawn ocean passages as curved lines. In reality, we use spherical trigonometry to manually calculate information about the great circle track. We can find the highest point, or the point where you're heading is due east or due west. We can also find the heading that we need to set off at, and we can find the location in which we cross each parallel of longitude. This effectively lets us plot a series of straight lines so that we can use the ship's compass to effectively steer us along a curved track over an ocean. Of course, modern navigational technology can plot the curve accurately, and modern autopilots can steer a ship precisely along that curve. So, next time you are crossing an ocean, you'll understand that even if your track doesn't look straight, you're probably still on the shortest route, and that's because of the shape of the Earth. Hopefully you've enjoyed today's topic. For more videos like this every other Friday, be sure to subscribe right here on the channel. And for those who have stuck with me through the summer break, thanks so much for your patience. We should be all back up and running on our normal schedule now. Until next time, thank you for watching, and goodbye.